Now in these slides, I will provide a brief overview of the tools that we have in CSD to do ligand-based virtual screening. The first one is the CSD conformer generator. CSD conformer generator produces realistic ensembles of low energy ligand structures, and these low energy ensembles are ready to be exploited for drug design in the presence and also in the absence of detailed knowledge about the three-dimensional structure of the protein active site. The second one is CSD ligand overlay. It overlays sets of flexible molecules that are assumed to be ligands of the same protein. And the final one is CSD field-based ligand screener, which is available through CSD Python API, which is a module that can be used to screen a library of compounds against a pharmacophore query obtained from one or multiple overlaid ligands. Now, in this next few slides, I will provide brief introductions of these three tools. The first one is the CSD conformer generator. So CSD conformer generator is a knowledge-based program that uses the wealth of knowledge in the CSD to explore the conformational space of small molecules and generate plausible conformations of a small molecule. The CSD conformer generators provides the ability to both minimize molecular conformations and also generate diverse conformer subsets based on CSD data. So given a molecule in 3D, the bond lengths, angles, and the dihedrals are minimized based on average values taken from Mogul, and then the rotamers and ring distributions are assigned. The new versions has improved handling of flexible ring systems. It is fast and it is useful not only to generate plausible conformation of specific compounds, but also as optimization step to prepare compounds for virtual screening. CSD conformer generator available as standalone executable through CSD Python API. It is also available through Mercury interfaces and also through a script in Hermes interfaces. And this tool has been evaluated extensively against Platinum dataset, which has been mentioned in this literature here. The second tool here is CSD ligand overlay. So the purpose of the software is to overlay sets of flexible molecules that are assumed to be ligands of the same protein sharing the same binding site. Now, a correct prediction places the ligand of the conformation that they adopt when they bind to the protein. But the software works in absence of any protein structure information. So it is rarely possible to identify the correct overlay ambiguously. So therefore, what it does is that it provides a variety of credible solutions. This program represents each ligand by fitting points, which is basically at the feature, like chemical groups with particular physicochemical properties. Now, generally three types of features are used always, which is hydrophobic centroids, H-bond donors, and acceptors. Now, in addition to that, customized features can be defined, which is positive or negative centers. Now, this overlay program, ligand overlay program, has been also validated extensively using the AZ test set, which contains of 121 molecular overlays and mentioned here and in the publications, in these publications here. And the third one is a field-based ligand screener, which I mentioned before is available through CSD Python API. Now, how does it work? It generates a field potential from a molecular overlay based on user-defined atom types and then create fitting points in the hotspots. It requires two input files, one the query and the molecules to screen. Then what it does is that it then globally optimizes the translation and rotation of each ligand by generating conformer libraries and then feed the ligand atoms into the pre-calculated fitting points. And then it screened the ligand conformational ensembles against the overlay query and finally ranked the screen ligand. Now in this slide, I will show how in a ligand-based virtual screening workflow, CSD-Discovery ligand screening tools can be used. In the first step, the ensembles of conformers can be generated using conformer generator for a set of known inhibitors, and then CSD ligand overlay program can be used to generate the overlay hypothesis for this ligand, and a pharmacophore model can be selected for the next step. So next, in the screening of the library, CSD conformer generator can also be used to generate confirmation of the library of active and inactive compounds before or during the screening step. And finally, a library of active and inactive compounds can be screened against the selected overlay solutions by using field-based ligand screener, and all the enrichment matrix can be calculated. There is a full tutorial here in our website which shows that how to use these tools in a real life scenario, and also how to calculate all these necessary metrics which also can be calculated using CSD Python API modules.